Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Vadke. Today we will start with a new chapter, chapter 7, triangles. You have already studied about many properties of triangles in your lower classes. In previous lesson, lines and angles, we studied some properties about triangles like angle sum property and exterior angle property. In this chapter, we will study in detail about the congruence of triangles, the rules for congruence, and some more properties related to triangles. In today's video lesson, we will recall the meaning of congruence of triangles and also learn some criteria for congruence of triangles like SAS, ASA, and AAS. The word congruent means equal in all respect. This means that congruent figures, when overlap with each other, will completely coincide. For example, in the figure I have shown two circles. If I overlap the two circles, they completely coincide. We can say that these two circles are congruent. Likewise, if I overlap the two squares, they completely coincide with each other. That is, the vertices and sides completely coincide. So these two squares are also congruent. Likewise, if I overlap the triangles, the vertices and the sides completely coincide. And so we can say that these two triangles are also congruent. We notice that the vertices and the sides coincide. So in all respect means all angles and all the sides are equal. Notice that we were able to overlap these figures because they have same shape and same size. So congruent figures are those figures whose shape and size are same. We can find numerous examples from daily life where congruency of objects is applied. For example, two ATM cards which are issued by the same bank will have same shape and size. Otherwise, they will not fit into the slot provided by the bank in the ATM machine. Similarly, all 1 rupee coins that are produced in the same year by the mint will be identical and therefore congruent. Another example could be copies of photographs that you give for developing. So if you ask for 8 copies, all of them will be identical and hence congruent. So whenever identical objects have to be made, the concept of congruency is used in making them. Likewise, many examples can be cited. For example, you want to make chocolates which have identical shape and size. Then you will make identical molds for them. So whenever identical objects have to be made, the concept of congruency is used in making the molds. Let's understand the meaning of congruence in triangles. We have already studied in lower classes that two triangles are congruent if the sides and angles of one triangle are equal to the corresponding sides and angles of the other triangle. The sure way of knowing that these two triangles are congruent or not is by overlapping them. By overlapping, we see that the two triangles completely coincide with each other, such that the corresponding angles are equal and the corresponding sides are also equal. So this implies that there is one-to-one correspondence between the vertices of the two triangles. So by overlapping, we found that angle B is equal to R, angle C is equal to angle P, and angle A is equal to angle Q. Also, side AC is equal to side PQ, AB is equal to QR, and side CB is equal to PR. So let's write down the corresponding sides and angles. So vertex A corresponds to Q, vertex B corresponds to vertex R, then vertex C of the first triangle corresponds to vertex P. So under this congruence, we can write down triangle ABC is congruent to triangle QRP. It is important to write the correspondence of vertices correctly in order to write the congruence of triangles in this symbolic form. So if we choose an order of vertices for the first triangle, the same order has to be chosen for the second triangle. So if we write triangle ABC is congruent to triangle PQR, then this will be wrong because the order of congruence is not correct. And these corresponding angles and corresponding sides that are equal in two congruent triangles are written as CPCT, which means congruent parts of congruent triangles. Now let us establish some criteria for congruence of triangles. You have already studied in lower classes these criteria, so we will recall. Look at the first set of triangles, triangle ABC and triangle DEF. All three sides of triangle ABC are given, which are unequal. Triangle DEF is an equilateral triangle because it is given that all sides are equal. We can observe that only one side in these two triangles is equal. The other two sides of the first triangle are not equal to the sides of the second triangle. So these two triangles will not be congruent because their corresponding sides are unequal. Look at the second set of triangles. Triangle ABC has BC equal to 4 centimeters and angle B is 50. In triangle PQR, QR is given as 4 centimeters and angle Q is 50. So only one pair of corresponding angles is given equal and one pair of corresponding sides is given equal in these two triangles. Is this information enough to say that these two triangles are congruent? If you overlap these two triangles, they are not going to be covering each other completely. So these two triangles are not congruent, and hence this much information is not enough. That is, knowing one corresponding side and one corresponding angle equal of these two triangles is not enough information to say whether the triangles are congruent or not. Look at the third set of triangles. In the first triangle, side BC is given and side AB is given, and the angle contained between these two sides is given as 50. In the second triangle PQR, side QR is also 4, QP is 2 centimeters and the angle contained between them is also 50 degrees. Let's overlap these two triangles. So we see that in these two triangles, the sides and the angles are completely covering each other, which means that they are congruent triangles. So if we know that two corresponding sides of the two triangles are equal and the angle contained between them is also equal in two triangles, then the two triangles are congruent by the criteria SAS, side angle side. The angle is contained between two equal sides. So according to SAS congruence rule, two triangles are congruent if two sides and the included angle of one triangle are equal to the sides and included angle of the other triangle. Look at the fourth set of triangles. In this figure, we have two sides of the first triangle as 5 and 4 centimeters, and in the other triangle also two sides are measuring 5 centimeters and 4 centimeters. And we can also see that one corresponding angle in both the triangles is equal to 50. So are these two triangles congruent by SAS rule? We have two sides and an angle. The answer is no. Why? Because the angle which is equal is not contained between the equal sides in both the triangles. So to use this rule, the angle should be contained between the two sides. Observe the sides and the angles of these two triangles. BC of the first triangle is equal to PR of the second triangle. Both are 4 centimeters. Angle B of the first triangle is equal to angle R of the second triangle because both are 60 degrees. And angle C of the first triangle is equal to angle P of the second triangle. Both are 45 degrees. So we have one side and two angles of one triangle equal to one side and two angles of the other triangle. To know if these two triangles are congruent or not, we will overlap them. So on overlapping, we see that the two triangles completely coincide with each other. The arms and angles cover each other exactly, which means these two triangles are congruent. According to ASA congruence rule, two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. So what can we say about the third angle of these two triangles? Angle A and Q. Are they going to be equal? Using the angle sum property, we can find the third angle in both the triangles and we will find that they are also equal because they are congruent parts of congruent triangles. So the third angle will be 75 degrees in these two triangles. So if I mark angle A equal to angle Q and angle C equal to angle P and BC equal to PR, are these two triangles still congruent? Yes, they are congruent because we have confirmed it by overlapping. But we do not have the side contained between the two equal angles. So now we have another rule or criteria for congruence, and that is called as angle side. So according to angle side criteria, two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. Now try to find whether the given set of triangles are congruent in these two examples. In triangle ABC, angle A is 75, angle C is 45. In triangle PQR, we know two angles, angle Q is 60 and angle P is 75. So we have only one corresponding angle equal, that is angle A equal to angle P. However, if we find the third angle, it comes out to be 60 degrees. Similarly, we can find the third angle in the second triangle and it comes out to be 45 degrees. So now we can see that all the corresponding angles of these two triangles are equal. However, having all angles equal in two triangles does not guarantee that they are congruent. So we have side BC equal to side QR. So now angle B is 60, angle Q is 60, BC is 4 centimeters, QR is also 4 centimeters, and angle C and angle R are equal to 45 degrees. So we have two corresponding angles and an included side equal in these two triangles. So triangle ABC will be congruent to triangle. Write down the correct order of the congruency. Vertex A corresponds to P, vertex B corresponds to Q, and C corresponds to R by angle side angle. Can we say that these two triangles are also congruent by angle side? Yes, we can use angle side as well. Look at the second example. Angle M is equal to angle D and LN is equal to CE. Using angle sum property in the first triangle, we can find out the third angle, which is equal to 60 degrees. So we can say that angle M is equal to angle D, angle L is equal to angle C, and LN is equal to CE. This means that these two triangles are congruent by angle, and side. So triangle LMN is congruent to triangle CDE by angle side. If we find the third angle E in the second triangle, then we can say that these two triangles are congruent by ASA. Now observe these triangles. All three angles in all these triangles have the same measure, but these triangles have different sizes. So we can draw the same triangle having angle measure 90, 40 and 50 degrees with different sizes. So this means that they are not congruent. So having all corresponding angles equal in two triangles does not mean that they are congruent. With this, we come to the end of this video lesson. Your assignment is to write down the criteria that you learned in this class and give one example for each with figure. You can take the examples that are shown in the video lesson. See you in the next class. Until then, goodbye.